If you are building complex front-end applications that are deployed in multiple countries or use multiple configurations or are used by multiple customers, you might encounter some problems with performance or architecture or code structure. And today I would like to talk to you about our solution to these problems. We call it Buildtime modularization, and it's a way how to structure and program your application to allow for complex behaviors and complex business logic while keeping the application small, lean, and performant. Just a small disclaimer: the thing I'm about to talk today, the Buildtime modularization, it's not a library, it's not a framework, it's not an application. It's a way of writing and architecturing your applications. It's also not bind to any concrete technology. So I'm going to use Vue.js and Next.js as example later on, but you can use it with React or Svelte or any other front-end or back-end framework. So we at Magexo, we build eShops, and we build complex eShops that are deployed to multiple countries. And that means that the application has to have parameters. And what do I mean by parameters? Well, in different countries, the customer might want to have different images, icons, and styles, or static information like email in the head or telephone number in the footer. Sometimes we have to use different components for different countries. One country might want to have a different button for add to cart button. Some countries might have additional features, while other countries lack some features, or there are some temporary changes like Christmas theme or some weekly, for example, brand deals that are localized only to one or more countries. Also, fun thing is if some country has different business logic for some processes. For example, one country might require age verification during add to cart process, while other countries might not. And the most fun thing is when during the development, customer tells you that one country will be integrated to completely different backend. The application will still look and behave the same, just the backend is different. So, during our quest to accommodate this parameterization and to make it to have a unified approach how to handle all these different parameters, we encountered few things what not to do. The classic is ifs and switches. If you have small applications and you have only a few these parameters, ifs and switches are fine. But for large application, it's a really bad idea. It doesn't scale well. Sooner or later, you will have your application littered with thousands of ifs and switches, and you will be only adding more and more and more. Another approach that did not work for us was configuration objects. Again, for a small application, it's a perfectly valid approach. But in one of our applications, the configuration object had over 1,000 properties, and that's too many properties for anyone to remember or to recognize. So we didn't know what a lot of the properties did, or if they are even used anymore, and how they interacted with each other. Also, big negative impact of configuration objects is that you have to ship the whole object to the front end. So if you have large configuration objects, the end user will download lots of JavaScript and lots of data, which might be unnecessary. And if you want to really complicate life for yourself, I recommend doing all this parameterization over feature flags, or even use environment variables for it. That will make your life a lot of fun. So, what's the solution? The funny thing is that the solution is basically known, and it's modularization. If you talk to a lot of experts or even people in our field of work, you will hear a lot of about modules. A lot of people say you should structure your application in modules, you should use modules. Even JavaScript files in the ECMAScript standard are called modules. So why not use modules, right? Well, first we looked into some existing solutions, because you shouldn't reinvent the wheel every time you have an opportunity. And because we use Vue, we looked at Vue plugins, and they look like this. First you create an application, and then with the .use method you can add functionality or a plugin to that application, which is great for, here you can see I'm adding a router and global store to my application. And this approach is generally great and used, but it has few disadvantages. First, there's no tree shaking, because plugins are global. This means you have to download the plugin and add it to the application, even if it might not be necessary right now. For example, if I were to implement checkout as a Vue plugin, the end customer that will visit the page will download that checkout plugin on the home page, because you have to use it at the beginning when creating the application. And other disadvantage is that the plugins cannot interact with each other. For example, I would like the router to add functionality to my application routing, and I would like another plugin, checkout plugin, to add some routes to that plugin, which in Vue plugins is not that easy. Another existing solution we looked at was Next modules, because again we use Next, so why not to use modularity of Next? In Next it looks like this. You define the list of modules that should be included in the application, and Next does the rest of the work for you. This is actually pretty great, but again there are disadvantages. First, again, no tree shaking, because the modules are global. You will download the module even on the pages you don't really need them. So same problem as with Vue plugins. And again, the Next modules here, they can interact with each other, but it's really complicated, and we don't want that. So what do we need? First, we need tree shaking. We need the modular system to be statically analyzed during build time, so the compiler, for example Webpack, can decide which plugins should be included in which pages. We could let this work on the developers, but developers make mistakes, so it's better to leave it to the compiler. Another thing we need is interaction with each other. For example, we want modules to extend each other, to add functionality to other modules, or to even change functionality of other modules. If one customer wants checkout module, but they want to change one thing in it, it should be easy. They shouldn't have to rewrite the whole module. And last but not least, it has to be simple to use. So we went the way of convention over configuration. This means that there is not that many configurable objects, generally only one, and the whole system builds on conventions that are set. These conventions are most of the time are that you have to have a specific file with specific name in specific place, and if you meet these demands of the system, it will work generally great. So let's look at examples. So I will begin with pages, which are the most basic. We have application split into modules, and each module has its own pages directory. So I have modules directory with catalog module that has pages for product and category, and checkout module that has page for checkout. If you ever used framework like Next or Next, you might be familiar with these pages directory, and only difference here is that we don't have one pages directory for the whole application, but we have one pages directory for each module. So this will help with code structure and navigation in the large code base. And there's also a homepage module with, again, a page for homepage. And now I have one configuration file in which I can set which modules are enabled. If I remove some module from this list of modules and I build the application, the pages from that module will not be included in the final bundle. But here's an interesting question. What happens if two modules define the same page? So for example, if I have home page that has index.view page, which represents home page, and I have another winter sales modules that has same index.view homepage. What should happen now? Well, we went the way that the last module wins. So because in the array of modules, the module winter sales is after the home page, it will win, and during the build, the page from the winter sales will be used instead of the page from the home page module. So this means you can use modules, for example, to change home page for a week. You create a module which will have different home page, you turn it on, and at the end of the week you turn off the module and the home page is back to normal without you having to store the page in some version system like Git or store it in .old file or something like that. So this is generally great, but a lot of the times you want to configure only a component and you don't want to rewrite the whole page, only to change one component on that page. And there is one small problem, and that's import doesn't allow you for component overriding. Because if you use import like this, you have the module name or the information from which module that component comes in that import. So in the first import, there's not really a name of the module, but because it's a relative path and there's no name of the module, we know that it comes from the catalog module. And in the second page, we have basically absolute path using alias, and again, it says that's the button component from the catalog module. So we can't do the same overriding as we did with pages. We can't create a winter sales module that will come after the catalog module and will have button.view component which will override it. Or can we? What if we were to remove the module information from the path? So instead of importing in the classical way, we can import it like this. So we are saying we want something called button from the components directory, but we are not specifying from which directory it comes. And this allows us, if we have only one module that has button.view in components, this component will come from that module. But if we add another module, for example, winter sales, now if we build the application, the button will come from this module. So this way you can easily change components in the application by adding or removing modules. And those modules can be country specific or brand deal specific or whatever you need. And another interesting thing is extending or adding functionality. Now we imported only one thing from the directory, but we can also import all the things for the directory, which is great, for example, for payment methods. Because now I can have a module with, for example, Braintree module, which will provide me with Braintree cards and Braintree Google Pay payment methods. Another module with PayPal, which will provide the application with PayPal payment method. And if, for example, the Czech country want to have the PayPal payment method different, they can override it like this. And now that import you see at the beginning of the slide is in the checkout component or checkout page, where the application imports all the payment methods and can render them, display them, do whatever it wants with them. So these directories, we call them concepts, and we use them not only for components and payment methods, but for a lot of things. So here I have some examples. For example, repositories. We call repositories functions that communicate with backend. So because we have split them, we split the communication with backend into different concepts, into separate concepts. We can now easily change integration or add, remove, change integration to different backends. If we have, for example, get products repository that will get product from some backend, we can extend it, we can override it in another module which has repositories / get products.ts, which will get product from different backend. Another concept we use is GraphQL. Some countries might want to add, remove, or change GraphQL queries or mutations. So this is easy way how to do it. We use mixins for component logic. So again, we can add, change, or override component logic like this. Pages, I already talked about them. Another interesting thing is config. We use the whole configuration of the application in these concepts. So if one country wants to change some configuration, they can add a module which will override that configuration. And also interesting case, we have tests structured like this. For example, Cypress, which we use for end-to-end testing. Because Cypress tests the application as a whole, it's depending on the build of the application, how the application was built. So we can't have one general set of Cypress tests. We have to split them into these modules. So if you build the application, you enable some modules, you build the application, and you run Cypress. Cypress will run the tests only from the enabled modules. So you're not testing the functionality that is turned off. And also we have server code structured like this. Sometimes our applications have a little bit of server code, for example, for proxying or image resizing, and sometimes we need to change this. So we use this methodology for server code too. And all of this is configured in one configuration file where you set the list of enabled modules and which order they should be turned on. Here, for example, I want to add GTM to the application, so I enable GTM module, but GTM slows the performance down. And now there is a solution for it, Party Town. So I enable also Party Town, but if you enable only Party Town, GTM will still work the old way. You need to change a little bit of the GTM. You need to integrate the GTM into Party Town. So there's another module called GTM Party Town that will override a bit of the GTM functionality to make it work with Party Town. Another example is, for example, catalog module that will provide the basic general functionality for the catalog, like category detail and product detail. And if I want to integrate it with Magento, which is one of our integrations, I enable catalog Magento module that will provide the integration of the catalog module into the Magento backend. And by default, catalog does not have product labels. So if I want to enable product labels, I enable catalog labels module, and again, catalog labels Magento for the integration of catalog labels into Magento backend. So, what are the advantages? So first, this whole concept is tree shakeable because all of this is resolved during build time. Compiler can decide which files are included in which pages, in which modules, and create a minimal bundle size. Basically, the modules are compiled away during build time, so during runtime there are no mentions of the modules, they are only used during the build. It will also help you a lot with code structure. If you have large application, for example with thousands, hundreds of thousands of lines, each module will have only few thousands of lines. So if you know you have to fix something or add functionality somewhere, you are only operating over that module and you don't have to care about the rest of the module. So it's less brain work for you to comprehend how the module works. It's also scalable because you can turn on and turn off modules however you want. You can create a small and large applications this way. As I also talked, this approach is very flexible. We were able to integrate multiple backends without having to touch existing code. So, for example, we had Magento integration, and now we wanted to integrate our catalog into Ergonaut, which is different backend. We just added new modules, overrided the functionality, and it worked without us having to touch already existing code, which is great. And by the way, when we did it, the final bundle size was smaller than with the previous integration, which is pretty mind-blowing if you think about it. You only add new code, but the final bundle is smaller. And if you are fans of some programming principles, this approach also is pretty solid because you get a singular responsibility principle. If you have small enough modules, each module basically does only one thing and it does it well. And what is, I think, more interesting, you get for free open close principle. This means the code is open for modification because you can override it with different modules, but closed for modification because you can override the functionality without touching existing code. And it's also it also gives you dependency inversion because you are now not when you import something, you are not saying exactly where it should come from and exactly where it should be. You are only saying I want component that's called button, but I don't care what it really is. So here's an example. This is our demo application Storefront X that has some modules enabled, and it looks like this. And now we wanted to integrate it into different backends. So we wanted to have the same front end, same design, only maybe a few tweaks like different color, but completely different backend. And this is how it looks like. It's basically the same theme, same front end, but the backend integration is completely different. And another example is our customer wanted to have the same backend, but they wanted to have a completely different design, and this is how it looks like. Again, same application, but different modules turned on, different modules turned off, and it looks completely different, but it communicates with the same backend as the first demo application. So, if you are interested more, you can go to storefrontx.io and you can get in touch with us.